now that we learned how to use the built-in components to create a constraint, local one or a global one, let's do an example that requires writing a custom component. So in this puzzle we have 6 by 6 without regions. We have standard arrows, and we have a global restriction on that there's no strip of 3 cells in a line that all have the same digit. So let's try to add a constraint for that. Let's call it anti-tic-tac-toe. It's still global. In fact, I should be able to copy-paste a little bit from here. Yeah, sounds quite right. We just need to add one more cell. Let's comment that out for now. So again, we have a big complicated thing that we need to break into small components. In this case, each component would be like some particular strip of 3 cells in a line, and we need to tell it that one of the digits there is different from the others, and there's no standard component that does it, so we can build a new one. So the way to do is to add a new custom component and edit it. It creates a automatic name, but of course we want to change that. I don't know, let's call it different stuff component. So what we write here is exactly the name that we should use here. Let's remove everything else here. And now we need to understand what we have here actually. So we can see the template for different functions that we can uncomment and implement. We have get affected cells, get params, initialize, validate, and update. And I will go slowly over each one of them. So first of all, we need some way to provide the information to pass the information from here to the component. Like we need to construct the object somehow. And by default, it expects that the first argument is the component name, it's basically the description what it is and which cell it applies to. And the second argument is is an array of cell IDs that constraint applies to. And in this example, that's exactly what we need to do. But if it's not the case, then we will need to use the getAffectedCells and set params methods. For now, we don't need them, so I will just remove them. And I will show another example of puzzle where we will actually need them. And I think it's a good point to explain what is the name and how to create that. So before I do, let's just prepare this variable. Oops. So it would be easier to do the same. So basically, the reason why we need to specify a name here, it's mostly for debugging and to understand which component did some logic. So, for instance, if we do a logical step here, and it tells that the puzzle is broken, then it will say the puzzle is broken because of different digits here, or like this digit was excluded from here because of this component, or setting this cell to 5 leads to a contradiction because this component makes this digit different. Basically, like this name we will see here when we do logical steps. So it could be quite useful to actually include something meaningful here, and usually it's the name of the constraint and the cells that it applies to, and for that we could use the naming helper that will transform these cell IDs to something human readable. So let's do it here as well. And save the progress, just in case. But, of course, right now we added just an empty component. It doesn't do anything for us. So let's actually see how it's done. So the remaining methods are initialize, validate, and update. And let's I will return to the initialize later, because let's just remove it for now. Basically, usually you don't need that. So there are two ways to implement the logic in a component. The quick way is to use the validate function, and the hard but effective way is to use the update function. So let's try to do the quick way first. So basically both of these functions will be called at each step of the puzzle. Like before doing every logical step, Sudoku Maker will call to these functions if we define them. And the purpose of the validate function is very simple. It must look at the cells of that affect the constraint and tell if it's already broken. And the two main things that we will use for that is these two. First one, puzzle get value, and second one, puzzle get candidates. And and also there is puzzle has value. So instance that we have here is basically like everything that we have in the current object of the component. So we provided a name and the list of cells, so we will always have the name and cells here, so we can know which cell it applies to from here. Let's return to the defaults. So we can start from looking what it does from the template code. So it checks if all cells affected by the component are filled, meaning that they don't just contain different candidates, they contain only one candidate, and it's the cell's value. If at least one of the cells contains more than one candidate, then we say that everything alright, need to wait more to understand if it's broken or not. And it's okay to return like false positive results. The important part, if at least if our cells are filled, to return the truth. And in this code, it goes over all cells and says that every cell must equal to 1. So this method, puzzle get value, it obviously gets the digit filled in the cell that we asked for, and it's safe to use it before we already checked before that all cells are filled. But we need to remember that if cell has more than one candidate, that this method will return undefined instead of the value, because we don't know yet what is the value. So if we don't do that, we can check that the cell has value before calling this function, or another way is to call it first and then check if it's undefined or not. So let's see it all in practice. So we have this cell with ID equal to 0, and this cell with ID equal to 1. So what do we have here? What's the value of the row 1 C1? No value. We don't know it yet. What's the value of the row 1 C2? The value is 1. Does it have a value? Yes. Does the first cell has value? No. Now the interest things begin. Puzzle get candidates. So let's get candidates for this cell. So this method returns a set of all candidates, and it's an instance of where do we see it? Here, I think. Right, it's an instance of a Sudoku digit set class, and basically it behaves exactly the same as the built-in JavaScript set, but it's optimized for Sudoku. So you can just assume that you're working with a set, and that's all. So you need to know if it has 4 as a candidate. Yes, it does. Does it have 3 as a candidate? Somehow it does too. I don't know exactly. Maybe because I have the old instance of the puzzle state. You want to iterate over all candidates. You can write a loop like with every collection in JavaScript. Yeah. For some reason it tells that it has all candidates. But anyway, let's try it again. Maybe. Candidate. Yeah, it still says that it has all candidates. That's probably just the old reference to the puzzle. And also, if we want to convert a set to an array, we can do it with the decomposition like that. Now we have it as an array, and we can do anything that we do usually with the array, like something like that. But let's start from the most simple thing. Let's keep the template code that basically says this constraint will tell if it's true or not only if all cells are filled, and that's actually what we need to do. So we know in advance that we have 3 cells, so we can use that. And maybe we want to know the values instead. So now we have A, B, C, which are the values of our cells. So how to check that our constraint is correct? Well, we need to know that there's some pair of cells that is different. So, and it looks like it works. So basically, the reason why it's so fast, because it's the puzzle is already very restricted and it's 6 by 6. But usually just implementing the validate function is not enough, because like it tells if constraint, if the component is broken only afterwards, not before. It doesn't do any eliminations. So for instance, let's say we do it like that. See, we know by the anti-tic-tac-toe constraint that that's not a 1, because we have already 3 in a row, but it doesn't see it, because it cannot perform any logic step. So basically, the validate function is something that you can implement very quickly with this pattern, but it's useful only for the brute force checker, like or how we call it, solutions finder, and it could be very slow, because usually it applies only when we already know candidates, and it cannot do eliminations before that. What it actually can help doing is if we enable contradiction steps, then probably it should already be able to exclude 1 from here, because it will try putting 1 here, see that it's broken. Yeah, exactly. Placing 1 in this cell causes a contradiction, unable to satisfy anti-tic-tac-toe at these cells. So yeah, here we see why given a normal name to the component is could be quite important, because we see it here. That's exactly what we passed there, and now it can solve everything just by contradictions. But usually we want it to do some logic without the contradictions, right? So let's learn how to do that.